Let's go through question 1d from page 98 of the timed test 1 that's preparing for paper 1 of the Edexcel GCSE Computer Science exam in the revision workbook. So here, this is all about data representation of bitmap images. So if we read through the question, it says a bitmap image is represented as a grid of pixels. State, that means just write down, we don't need to explain, for 1 mark, what is meant by the term pixels. Pixel. Well, the question says that a bitmap image is a grid of pixels, and a bitmap image is just exactly that. It's like a map of pixels. A pixel is an individual coloured cell that could be any colour, and as you put those coloured cells together, it then represents a bitmap image. So the answer is the smallest item of information, the smallest picture cell that makes up a bitmap image. Then it says an image is 780 pixels high, which means from top to bottom is 780 of those coloured picture cells by 580, 580 pixels wide. So that's from left to right. You could count 580 coloured dots. And it's got 24-bit colour. That means that you have got 8 bits for red for each pixel, 8 bits for green for each pixel, and 8 bits for blue for each pixel. 8 times 3 is 24, so 3 bytes or 24 bits for every single pixel. So each bit, remember, is a 0 or 1. Each byte is going to be a number between 0 and 255. So you can have a number between 0 and 2 to the power 24 minus 1. So that's a lot of different colours that you could play with here. So quite a lot of colours to play with. And it says construct an expression. That's an important phrase that you recognise. It means you don't need to actually do the calculation because you haven't got a calculator in the exam. But you do need to write down all of the workings out, all of the numbers you would put into a calculator to calculate the file size of an image in kibibytes. So the size of a file is the width times the height times the colour depth, as in the number of bits per pixel, divided by 8 to get into bytes from bits, and then whatever else you need from the unit that we've got here. So what unit do we want? Well, we write down our acronym. We start with bytes. I suppose we can have bits before that. And then kangaroos make giraffes take photos. We have 8 bits to go from bits in a byte. We have 1024 bytes, and then 1024 kibibytes, 1024, 1024, as we go through mebibytes, kibibytes, tebibytes, and pebibytes, etc. So we're just going to need 1024 to go from bits to bytes and from bytes to kibibytes. So let's plug our numbers in. Width times height times depth means 580 pixels across. Height is 780 pixels going up, so that's going to be 1 mark for those two numbers multiplied together. Multiplied by our colour depth, that's 24 bits, that's our second mark. Third mark for dividing all of that, and then fourth mark for dividing it by 8 times 1024. Okay, so the last question says lossy compression. There's 2 types of compression, lossy and lossless. Lossy compression in this question is often used to reduce the file size of images. Describe, so that's more than state, 2 marks here, how lossy compression reduces the size of a file. So let's describe it. I'll go into Photoshop and show you a picture of a rainbow. And if we use a lossy compression algorithm, like JPEG, and take the quality down, you'll see the file size at the moment is 252 kilobytes. If I take that all the way down, maximum compression, it's gone down to 27 kilobytes. And you should be able to see the compression artifacts here. It's not pixelation, it's compression artifacts. Let's zoom in so you can see a bit better. Take the quality back up. So what happens, it uses a very clever algorithm to take a reasonably good quality picture to get an approximation of it. And you can see as we reduce the quality, the number of colours is reduced, so there's some colour banding, and the pixels are kind of grouped together into boxes. So this looks nasty and boxy here. So the human brain is amazing. It can work out that it's still a rainbow, but it's impossible to work back from this compressed version, this lossy compression, to the original if you don't have the original already saved. So what does the answer say? How do we get our marks? It's saying some of the data is permanently removed. You can't reverse lossy compression. So there's your 2 marks. Some of the data is permanently removed, which means that the file cannot be fully restored to the original. The other type of compression is lossless. So that might be, say, PNG compression. It does reduce the file size slightly, but not nearly as much. But it is possible to reverse lossless compression.